But next up, we got Pratik. And what are you talking about again? Oh, we haven't got a slide. Oh, security, which is kind of good. There we go. So I think we're all here. Well, it's a few stragglers, but please welcome Pratik talking about serverless security.
Hi. So, well, first of all, thanks to the sponsors, of course, because all the food and the venue comes from them. So my talk is on Azure Serverless Security, and depending on how it sounds, but it's basically talking about a particular architecture, very common in serverless, specific to Azure, and see how we can secure that architecture. Now, it's really 101 if we do the without security, because we have probably everybody in the room has done it already. So there's a challenge from Lars in the morning, and there should be a special prize for that, which was how do you define serverless architecture? This definition is from Martin Fowler, cannot be challenged. Okay. Okay. So we can read that one, but what it means is that oftentimes there is some sort of a backend as a service, which sometimes we don't talk about. We talk more about the function as a service. So function as a service is like Lambda functions, but this backend as a service, things like DynamoDB or Firebase or Azure Table Storage or Cosmos DB, things like that. So they're sort of part of the serverless as well. So a very simple architecture diagram would be a single page application which is hosted from some sort of serverless platform like blob storage or S3 that calls some sort of function as a service, which can be an Azure function or a Lambda, and that goes to some sort of backend as a service, which is probably DynamoDB or in case of Azure Table Storage or Cosmos DB, some sort of NoSQL storage. The important thing is that we don't care about these servers underneath. We already know that one, but also they sort of scale based on request volume, and you pay per request sort of thing. That's the serverless model essentially. Now, when we talk about security, we know that in cloud, security is sort of everybody's responsibility. Your cloud provider has some responsibility or more of the physical aspect of security, the data center, the machines, the network, things like that. And then as you move up the stack, your responsibility comes as well. So everybody is responsible for this development team, if you have a SRE ops team, your security team, and of course your cloud vendor. How much security you want depends on your threat model and other things. So there's no one size fit all solution for cybersecurity. I'm going to show one example of what we can do, but that's not the only solution. There may be other solutions as well. Because let's talk about security, I mean, one of the fundamental things is securing your Azure account. And there is a very nice post from Microsoft, which you can, it is a very nice read actually, that your password actually doesn't matter if it's complex or simple, or it really doesn't matter, and they explain it very nicely. What matters is setting up multi-factor authentication. That stops 99.9% of all attacks. So that's very important. So if you, actually I haven't got MFA on my own Azure subscription. I got on the work subscription, not the personal one. I should really set it up. Okay, but that's sort of, okay. Now there are things called APPSEC practices. We all know about, we have probably heard about this one, the Equifax breach that happened in US, and a lot of data was lost, and they're still paying some compensation, a fair large amount. Why? Because they didn't update the Apache Struts, which is a library which was vulnerable, but they didn't update it. So that's the consequence of that. There's a cybersecurity warning to drop Python 2, because sometimes we don't look at the currency of our frameworks and platforms. So that sort of comes in the picture as well. Do you know about what sort of the dependencies you are taking? Because we don't scan the vulnerability dependencies. Hey, there's that new NPM package. Let's just download that one. So just this year, there were 12 OSS packages where malware code was somehow it was introduced, and people are just downloading because those libraries are very well known, things like that. So there are standard AppSec practices, and this is nothing to do with serverless. It will pretty much go whatever app we are doing. So these things are sort of the basics. So we have to do these things like do input validation, do logging and monitoring, enable HTTPS only with the secure version of TLS 1.2, check your framework currency, scan for your dependencies. So this talk is not about that, because this is something like should be bread and butter. What we're trying to talk about is a very simple reference architecture in serverless. This is very typical. And in Azure, it will be looking like there is a storage blob which serves some static content. So that's your single page application. that calls into APIs which are a function app in this particular case. So this is serverless, and the functions call into some sort of a backend as a service, a serverless NoSQL database. The two main options in Azure are table storage and Cosmos DB. So that's the architecture that is very, very common. We probably have implemented it, but have we implemented it in a secure context? That's the talk about. And if I may just go one more. So we can augment this one by putting this excellent thing called API management in the middle of the SPA application and the functions. API management, for those who don't know, is a API publishing gateway in Azure. The good thing is that there is a serverless SKU or tier of API management that very recently came in. Previously, API management was sort of like you have to predefine the size and the SKU, like it's a premium with how many scaling or is a standard, things like that. So now there is a consumption tier version of API management which will scale based on the number of requests that is flowing through it. Azure functions are also like a consumption and request based model. There are version of functions, Jeff's not here, but there are version of function called premium functions now, which is more sort of like a dedicated sort of model, but we're not going to those things here. So this talk is purely serverless. There's no server involved, there's no dedicated resources involved. You don't have to pre-provision anything in this model. And we're just introducing API management in the stack. So that's what we're going to do. So I could go to the Azure portal, but that would probably take more time. So I've got screenshots of most of them. So in Azure in Azure Storage account, you can host a single page application as a static website. All it means is that create a storage account, enable the option for static website, say which this is the it gives the URL for that website, and it says what is this starting document and the error document, and then you can upload your JavaScript, images, HTML, CSS, all those things. It will be served from there. So now it's a serverless model because you don't have a server. It's like a static hosting only. You can augment it with CDNs and other things, but the very basic this will work. So I have got an example app like that, which is a single page application, and this is like a simple TODO app. It's just using JavaScript and HTML. It will call an API, which will like it can search for TODO or save a TODO, something like that. And all the app does is these things. So there's a function URL. You click the button. It calls that URL with the ID if I'm searching for it with get. That's all the app does. And I'll try to demo that app as well. The function. So this is a function app. It's got like the create, read, update, delete sort of REST API in here. And we can see that there's a create to do, delete to do, get to do by ID, get to do. So this is a function app with like 5 functions in there deployed to Azure. And if you see this one, the auth level is anonymous. So by default, functions, there's no authentication. Anybody can call that function. So that's how it starts. That's the baseline. And this function writes this data into a table storage. So that's a serverless NoSQL database. So this table storage is basically simple. It's got a key, and it's got some task name, and it's completed, things like that. So that's all. And how do we connect to the table storage? Obviously, there is a connection string, and we don't write it in the code. There's a lot of code with connection strings in GitHub. S3 bucket connection strings. GitHub is running regular scanning to detect them and warn people nowadays. A lot of S3 buckets got hacked like that. So at least we have in functions application settings, which are like which will come back in your function app as environment variables. So that's how we do that 12-factor app, and also your connection string is there. The question is that is this app secure? Is this app secure? Is anything guarding this function? No, really nothing, because it's anonymous. The only thing is that there is a course policy here, because otherwise JavaScript won't be able to call this function, but which means that another JavaScript, another hosted website will not be able to call this function, but you can call the function like using curl or some other tool or something like that. There's no security here. There's a bit of a security here in the sense that we are storing the connection string in the app settings. As long as that is not logged, those values are not logged, there's no other people accessing that one, or if you trust your Azure tenancy, probably good enough, but I put it as an orange. In fact, it's not very secure, but there is something there. And at this point, let's do a demo. So this is my serverless application. Just refresh the page. And I'll grab a task ID which I know is there. Function is warming up. Okay, I got something back here. So that was this request that went through this thing. But this request, anybody can do this request. So there's really no security here. So what is that we're trying to do? We're trying to see how we can secure this thing. So our problem statement is effective with these two. How can we make sure that the REST API calls from the SPA to Azure function is secure? As in, only authenticated and authorized users can invoke the Azure function, not anybody on the internet, because Azure functions are by default internet exposed. And the other thing is that how can we make sure that only the Azure function app can access the backend database and secure the credential? That's the two things that we'll try to solve here. And how do we solve the first problem? I mean, this is a pretty well-known thing. I mean, if you know about OAuth and OpenID Connect, we know that is to introduce a implicit flow for a single page application, but that's the recommended thing. So that's what we're going to do now. In this case, I'm going to use Azure AD as our OAuth provider. So that's what I'm going to do. The steps to do this are quite a few. So I'll just go through a slide very quickly. One, we need to register our single page application in Azure AD as an application. If you do that one, Azure AD will show that, okay, this is a registered app and there is a client ID for that app. So this identifies the app. Step number 2, we registered the API function in Azure AD as well. This can be done from the function portal. And that sort of registers this. The function as an application is called its own client ID as well. And this is our tenancy in Azure. Step number 3, we secured the SPA app with a login, of course. And there is a ADAL.JS library. There's a newer library which I haven't used called MSAL.js, but this is the older library, still works. So here I'm trying to say, okay, these are the things. So this is my tenancy. This is the client ID of the TODO app, and this is the resource, or this is the API, the ID of the API that I'm going to call. So I'm just configuring these things. Next I'm going to do is a login. So I'm getting authentication context, and I'm saying that when I click the button, just login. So this will go to the login screen of Microsoft tenancy. If you're already logged in, it will do SSO in that case. So that's what will happen with me. But we log in. That's what we do. After we logged in, when we press the button to say call the API, at that point we need to get an access token, because the access token is the one which is like a bearer. You give it to the API. The API should validate that one and say, okay, I accept this token and I'll let you pass through. So that's pretty easy in ADAL as well. So you pretty much call acquire token with or without pop-up, and then you put the API ID. So this is the resource server, or this is the function apps ID that I'm going to get a token for. And this thing will return a token, and this token is automatically cached by ADAL. So there is a thing that if it is already in the cache, you don't need to call that thing. Okay. And then we can call the search API with the token. And how do we use it? We pass the token in the authorization header as a bearer token. So that's what we're going to do. Now, even if we do this one, it still doesn't make the function secure, but anybody can still call the function. Like somebody can steal the token from a browser cache, or somebody can sniff the token and still call the function. Okay. Now, functions have a thing called a function level authentication. So you can change that from anonymous to function. What this means is that instead of a anonymous call, you need to pass a function key to the function for it to go through. Now, function keys, this will be available on the Azure portal on the function configuration manage blade. But the problem again is it's a chicken and egg problem. Where do you send the key from? If you send the key from the JavaScript code, which means the key is in the SPA, and that doesn't make it secure anymore because that's discoverable. Okay, so we have to put something in between the SPA and the function, and this is where enters Azure API management. So Azure API management, as I told, is a API gateway. We can publish any REST API through API management. There's a inbuilt way of doing a functioner because API management knows about functions, so it's like a one-click option that you can do. But if you have a Swagger, you can do it through that path as well. So API management reduces the attack surface. So what we can do is that we can save the API key, which if you do that one-click thing, it automatically does in the background. It saves the function key as a setting, and it passes the function key to the function when the function is called. So it's guarded inside API management. We can of course set that course policy because now we are calling API management of the function, so the course policy has to be set on this one. And we have a VALIDATE-JWT policy here. So this will inspect that access token, and it will check whether this is a valid token or not. And it can do other security things like rate limiting and all, which I haven't done. So we can easily publish a function into Azure APIM. And there's multiple ways of doing it. You can go from APIM and add an Azure function, or you can go from function and say publish in APIM. Both of them will work. Once you do that one, so this is a TODO API, and these are the operations that come into API management, and the backend is now this function, and this is, you can see this is the path it will get called and all. In there, we configure a VALIDATE-JWT policy. So policies are like checks that you can put during your inbound processing or even outbound processing. Now, it doesn't show the policy here because I put the policy at the API level for all operations. This is just showing for a specific operation, so the policy is not just for this, it's for all of the APIs. So that policy now validates that, okay, it requests to validate the expiration time. Has this token expired? Because tokens got an expiration time. It checks that one. It checks whether it is a bearer token. It checks whether it is a signed token. Then it checks, okay, how do we know it's signed properly? So we have to go to this OpenID sort of a metadata endpoint for Azure AD with your tenancy, and it will know what are the signing keys and all it gets from here. So it will check the signature is valid and it is signed by a correct correct keys. The audience, it will validate the audience. So this is the API that you are going to call. This will be in the token. It will validate. Okay. Now this doesn't show the value here because the value is coming from like a name value setting in API management. But this would be that GUID of the API. What we are checking here. It will check who is the issuer of the token. This must be from your Azure tenancy and not from everything else, especially unless you're doing a multi-tenant or something like that. And it will also check that the app ID. This is the TODO apps client ID. So this is the caller app. It will check whether that's correct as well. So it's going to check a lot of these things, and it checks whether this token is valid or not before it let the call go through. And let's see that one in the demo. So here I have a secure version of that TODO app. So I'm going to that one. And I'm going to log in. If I actually it's already logged in, so it's because of SSO. I'm already logged in, and I'm going to check this again. So if I bypass this all, this is a code that I have got that if this is checked in, do not send the token, and it will fail. But I'm not going to show that one. So this will now pop up, and this is the point where it is asking for the access token. Now you can do a silent one without a pop-up if you're already signed in, but this is to show it explicitly. So what happens here? See, this has got this JWT here. I dump it in the console, but it's also stored in the session storage. So if I inspect the token, we can see that the audience is here. This is the the ID for the function app. There's the issuer there, so it's issued at time, not before expiry. So it checks that expiry as well. The policy will check that one. The app ID is the client ID of the TODO app, the SPA application that is registered in AD. So it checks all these things, and there are few other roles in there. So it will check that thing, it will let it go through, and it should have come back by now. Yeah, it does come back by now. Now, so this is that API management, and if we go and do here, might have to refresh this thing. So this is the policies. So this is where I have the course policy and the VALIDATE-JWT policy. You can actually check this one in the policy XML file. So course policy allows the static website URL, so that can call this API, and the VALIDATE-JWT is validating exactly what I show. So that's how this is working. And in the named values, this is where the API management stores it. So you've got I've stored the audience, the app ID, and the function key is stored as a secret in here. So this is the function key. So if we go to the function, this is the function app. If we go to any one of them, let's say get TODO by ID, if we go to manage. So this is where you can get the function keys. Now you get a function key per function, but you get host key, which is for the entire app. I have used a host key here. That's what the default in APIM is, the one key for the whole of the app, and it is that automatically generated key here. But you can create your own keys as well. So if the function doesn't get this key, it will not let the call go through, and you can see that because this will show that this is now a function level authorization. Now, do you think that this is another thing we'll see here while we are there? Yeah, we're storing some things in here. But do you think that this function is secure now? That's the question. Who thinks this function is secure? Well, it's actually not fully secure at this point yet. So we have introduced a few things here. So we have made it better. We have introduced a JWT here to call from the SPA application to the API management. We've got a function key. So if you don't have the key, you cannot call this function. You can introduce like a client certificate management here as well. A little bit more complicated, but probably a bit more secure. But this function is not callable if you don't know this key. And this function still calls the database in the same way. The problem here is that what is the JWT actually validating? This is validating whether there's the audience, there's the issuer, there's the app ID. It validates the validity of the token itself. But anybody in your Azure tenancy can get this token. Like anybody can literally log into the SPA application and call this thing. How do you know that? Like, okay, Pratik can call this SPA application and see the TODO, but like Rahul sitting there is not allowed to use this app and call that function. So that's not something that is still there. So this is open to everybody in your Azure tenancy, better than the whole of the internet, but still there is something lacking there. So this is how it gets a bit more hairy. So what we have to do is that we can introduce a thing called roles. So if we go to that function app that is registered in Azure AD, there's a thing called Azure AD application manifest, and where you can edit that JSON file and we can add some roles in there. And we can grant user to those roles. If you do that one, and this can only be done by AD admin, then in your token, which actually I had because I had the roles already, you will see these things called roles. So now it shows that, okay, I got the normal things like the audience, the app ID, issuer, but I also got these roles, and these roles are only available if you were granted this permission on that API in AD. And now what we can do is that in the function app, okay, in the function app, I get that request header, I get the authorization header, I can get the string out of it, and then I can validate that JWT token explicitly, and I can check that, okay, has it got the claims? And this is some of them already checked in the the API policy as well. But this is the important thing. Now I can check is this role available or not. So this role will not be available if you have not been granted that role in Azure AD. And this is the authorization. So you got the authentication part of it. We know that you got a valid token from Azure AD, but are you authorized to call this API? That's the next level, and that's what we can do. And at this point, what's happening is that the JWT is passed all the way to the function, and then we are kind of checking the claims and validating the roles that you are in. So that gives a thing that whether this, and you can have other things, like this is an admin user, he can delete the to-do. When this is a normal user, he can only view the to-do. So you can do all these things once you introduce that concept of roles. And Azure AD does have that one. Okay, got very quickly I'll show that one. So now I am in the Azure AD, and I've got these two applications registered. So one is the to-do app. This is the SPA application, and other is this function app. The SPA application we have already seen, but I'll just quickly go over it. So this is we've seen this one. So this is the sort of the app ID in the token, and the other thing is this is the function app. So this is a thing called manifest for application, and this is something that you can edit here. I don't know how to do it with ARM template, but you should be able to do it in that way as well. I have done it manually. So these are JSON, and this is for the, okay, I've got two application roles. This is something I created completely manually. It shows okay, this is allowed by user. You can also have app roles as well, like for sort of service to service communication, and then you give it a GUID. So you have to generate your own GUID and say, okay, this is the name of the role, and this is like a description of the role. So I've got two roles defined here. So once that's defined in the manifest, we go to enterprise applications blade, and this is where you will have the application, and this one will now show. Now you can add user. So I can add another user from my tenancy. So let's check one. Like example, I can this one, select this one, and then if I want to do, I can say, okay, I want to give which role for that application to this user. So if we do it like that, you can do it to group as well. So that's the next level that we're talking about. So go back to the slides. So we have secured the first two version of it. The last bit that is remaining in 2 minutes is the call from the database connection string security. Now normally you would put connection strings in the app configuration file. It's really not recommended. Azure's got a service called Azure Key Vault where you are supposed to store all the secrets and everything. Now we can store the connection string as secret in a key vault. Then the question is that what's the credential to access the key vault? So it becomes a chicken and egg thing. So Azure has a thing that it's called managed identity for Azure resources, also previously known as MSI. What happens is that if you register an application as a MSI, it pretty much gets a default system identity from Azure AD, and internally how it works is that there is an endpoint which is available only on the local host. The app can call that endpoint with a secret that's also available as environment variable, get a AD token, and it can present that token to whatever service like Key Vault or Service Bus or Cosmos DB or whatever, and it will know what app is calling that one. So you don't need to do anything specific for this one, because these credentials are available from a local host endpoint, so it cannot be called from anywhere else. That's how it works. Very quickly, how it works is that we go to the function blade, and we assign an identity. You can do a system assign identity simply. You can do this one a bit more complex, and this creates an identity for this function app and with a sort of object ID or a GUID. Next, what we do is that we go to Azure Key Vault. We create a secret. Secret is something that you want to store in Key Vault, and you put that connection string value in there. So that's pretty easy. Then go to the Key Vault and grant this identity, which is this function application, exactly the least privileged thing you want to do. You want to say, okay, I want to give this application only get access to a secret. No key access, no other access, no certificate access, not like delete access or anything like that. So you grant that application. So this application through that managed identity can only do this thing, get a secret from a Key Vault. And the third thing is that instead of the real connection string, in the app configuration, you can set it in this format, Microsoft.KeyVault secret URI equal to, and give it the whole URI of the secret. So this is a special format which the function runtime understands, and what it will do is it will use its own managed identity to get a token, and it will call to get the secret for that key vault. So that's sort of built in. So you don't store the real connection string in the function anymore. You store a pointer to the key vault, and the key vault has granted access to the identity of the function. So this is actually called credential-free code. So you don't, so the code doesn't need to keep any credentials. So that's the recommended pattern. And then this becomes fully secure because this JWT here, there is JWT and function key here, could have been a certificate as well. And then there's this managed identity AD token. So we have secured this entire stack in a serverless fashion. This is what our architecture looks like, very, very simple. It kind of shows that where things are, what things are flowing, what's happening at each point, and there's this key vault with the access policy and things like that. So key takeaways would be, so implement OAuth implicit flow in the SPA to get the access token, and this you can actually do with any other provider like Auth0 or Okta or whatever. So this was an example for Azure, but same principle really applies. Register the SPA and the function app, create app roles in the application manifest, grant roles to users in AD, publish the function app in API management, validate the JWT token in APIM policy, and check the roles in the claim within the function app code. And then for the last bit, set managed identity for the function app, store typo, connection strings as secrets, grant least privilege access policy, and change the app configuration for function app to point to key vault. Using the managed identity, you can also like connect to, like if you want to, like when a TODO comes, if you also want to send a message to a service bus, you can do it using the managed identity. So, but you have to do it a bit explicitly because there's a binding in function app still doesn't work with the managed identity out of the box, but you can do that one. So you don't have to store any username, password, connection strings anymore. So that was my talk, and thank you. Yeah.